10 years ago, a remarkable suite of instruments took to the skies, aboard the first of a series of polar orbiting weather satellites known as the Joint Polar Satellite System. This is the story of the satellite that led the way. It has measured storms, fires, volcanoes, and oceans, changing the way we view the Earth, improving our weather forecasts, and carrying on critical long-term measurements of our planet.
4, 3, 2, main engine start, 1, 0, and liftoff.
On October 28, 2011, the Suomi-NPP satellite lifted off on a Delta II rocket from Vandenberg, California. Named after Werner Suomi, who invented the first spin-scan camera to observe weather from space, the satellite marked the beginning of another new era, the Joint Polar Satellite System, a mission to provide valuable weather and environmental data into the 2030s. And during the last decade, Suomi-NPP has become well known for its blue marble images and also its day-night band, which show us power outages after storms and human activities at night, such as highways, sea travel, and natural gas flares. Continuing observations begun by satellites like NASA's Terra, Aqua, and Aura, it allows for a number of products that help people on the ground. Its data allows us to map wildfires, track the movement of wildfire smoke, and then measure the air quality as that smoke moves through an area. Measure the insides of hurricanes and reveal the structure and intensity of a storm and the ocean's surface temperature that fuels it. Track the health of major crops worldwide by showing how they're impacted by weather and temperature. And measure emissions from volcanoes that help determine air quality and visibility for pilots. Over the last 10 years, NPP data has increased our understanding of major events, like the life cycle of Hurricane Sandy, the carbon released by Australian bushfires, Saharan dust storms across the Atlantic, and emissions decreases from the global pandemic. The Joint Polar Satellite System's next satellite launched 6 years later in 2017, and its sister satellites will launch over the next decade, continuing these kinds of vital measurements in the years to come.